Chapter 6.3, multiplying and dividing rational functions. We talked about rational functions last time. There is a function that's made up of a polynomial over a polynomial. I don't know if you recognize this. It's a character from SpongeBob. It is the hash-slinging slasher. And it reminds me of this lesson, and you'll see why, especially the slasher part. So I have to show you a picture of the hash-slinging slasher. Okay, we're going to start though by getting the prime factorization of these two numbers. So this is a factor tree. This is stuff you did a long time ago. So 72 we have 8 and 9, and then 8 we have 4 and 2, and 9 is 3 and 3, and then we can factor 4 down to 2 and 2. So it's prime factorization because we've factored it all the way down to its prime numbers. So now I've got 2 times 2 times 2 times 3 times 3. Okay, 20, I've got 4 times 5, or 10 times 2. It doesn't matter. You'll get the same prime factorization. Okay, so I have 2 times 2 times 5. Okay, so with this information, what is 72 divided by 20? Okay, this is where the slashing part comes in, and it's fun. Okay, I've got 2 over 2, that means it's 1, right? So I can slash that. I've got another 2 over 2, I can slash those. So I'm left with 2 times 3 times 3, which is 18 over 5. Okay, pretty easy. I know you guys have done this before. Now we're going to apply it to polynomials. Okay, so what we need to do is we need to get these down to their prime factorization, and then we can start slashing. Okay, so this is, when I factor it, I get x minus 6 times x plus 2, right? Because negative 6 times 2 gives me negative 12. Negative 6 plus 2 gives me negative 4. And then x squared minus 4 is just x minus 2, x plus 2. And now we get to slash. We've got x plus 2 on both of those, and we're left with x minus 6 over x minus 2. Now one thing to note is that in this expression, x cannot be 2 or negative 2. And in this expression, x can't be 2. All right, so if we look at that on a table, what we notice is that all of these are the same, okay? Number 2 is undefined for both of them. The one that's different, the one that has different solutions, x values or y values, okay? The one that's different is the one that x can't be. So x cannot be negative 2. All right, so let's try this one. This one we have x minus 3 times x plus 1 over x minus 3 x plus 2. Slash, and I have x plus 1 over x plus 2. Okay, in this one, x cannot equal 3 or negative 2. In this one, x cannot equal negative 2. So the one that's different, the one that is not the same thing, is the one that x can't be. So when they ask you that on your homework, that's what you've got. Okay, so finding the product. These are, well, they're different because we don't have, they're polynomials of one term. And what I like to do with these is I like to take care of the numbers first. And in this case, I have a 4 times 2 in the denominator. Oh, let me back up. Remember that when you're multiplying fractions, you multiply the numerators and you multiply the denominators. Okay, and then you cancel things from the numerator and the denominator. So 2 times 4 is 8, and I have an 8 up there. So I can cancel all of those. And I'm left with 7. Now, the rest of it, I like to actually multiply out, because if you slash too much and you're putting like different exponents and stuff, it just gets really confusing. So now I'm going to combine this one. So I've got 7x to the 7th over y to the 4th, right? X cubed plus x to the 4th is x to the 7th. Y times y to the 3rd is y to the 4th. And in the denominator, I have x times y to the 3rd. So my final answer is 7x to the 6th y. Okay? And you should know how to do that. Okay, so here's one for you to try. If you want, you can pause the video. If not, I'm just gonna keep on a-rolling. Okay, so this one, what I did first is I canceled out this 3 and turned this into a 3. So 3 goes into 3 once, 3 goes into 9 3 times. Then I divided 2 out of each of these. So this is 3 and this is 4. And now I see I'm left with a 3 and a 3, so those cancel out too. So now on the top I'm left with x to the 6th, y to the 4th, over 4, don't forget that that's in the denominator, x to the 4th, y squared. And when I reduce this, I have x squared, y squared over 4. All right, I've got to move on in the next video.